presentation today is really going to focus on ionic rare earths and its position and the role that it's going to play in the sustainably sourced magnet and heavy rare earth space for this new cyclical economy. Now, let's just look at this from a bird's eye view. The rare earth element supply chain and ionic rare earths integration. How does all this fit together? What are we trying to achieve? So there's just a very simple explanation of the supply chain as it stands now, and it includes everything from the primary supply, which is typically exploration and mining, through separation and refining, and then through the different activities of metal making, alloy making, magnet making, component making, and then eventually final products. Now, we aim to position ourselves across the total supply chain, and we've done that up to this point through our subsidiary Renzori Rare Metals that covers the primary supply side of it with the Makutu project in Uganda. We've recently started this month, we announced a JV with Viridis in Brazil, where we aim to cover the separation and refining. And then through our 100% owned subsidiary in Belfast, Ionic Technologies, we're looking at capturing the rest of this, the metal making, the magnet making, and then the recycling of all of that back into our facility. We aim to do that through our technology, but also through the partnerships with Less Common Metals and Ford. So as we go through this presentation, I'll give you an update on where we are with Ionic Technologies, with the Viridis joint venture, and then Renzori as well. The headline on Ionic Technologies at this point is that we are now the first producer of recycled magnet rare earth oxides in the world, excluding China. And we've started 24/7 production at our demo facility on the 22nd of March, which is a massive milestone for us, and demonstrated our ability to commercialize this technology now. What do? Well, we take mixed grades of waste and from magnets, wherever they come from, in whatever shape or form they come from, and we process them into very high purity separated rare earth oxides. And the ones that we've completed and also used for marketing purposes is neodymium, praseodymium, and then an NdPr, as well as a dysprosium, terbium, and a holmium oxide. So these very specific high purity rare earth oxides is used in very high-tech applications all over the economy, but anything from EVs right up to wind turbines. And it all comes from a secondary supply through the recycling process. The competitive edge of our hydrometallurgical process is the fact that it's input agnostic. It doesn't have to have a specific grade of input into the recycling process to get the high purity rare earth oxides out of it. So unlike any other recycling process, we can take any mixed waste magnets, swarf, regardless of their type, age, coatings, etc., and still get it out. Belfast, why Belfast? Why aren't we doing this in Australia, right? Belfast is a strategic location specifically for the fact that we've got deal market access to the UK and the EU, the UK through the Windsor Framework and the EU through the Critical Minerals Act, and also to the US through various initiatives that they are running. So that deal market access is really useful to us. And also, more from an infrastructure perspective, Belfast Harbor is a very high quality piece of infrastructure. It's a deep water harbor, and one of the few in Europe and the UK that can actually decommission wind turbines. So these wind turbines comes into the Belfast Harbor to be decommissioned, and that's exactly where Ionic Technologies is situated, to grab that opportunity to recycle the heavy rare earths out of the turbines. Where are we with Ionic Technologies today? Where were we? Where are we? Where are we going? What's the plan here? So as recently as April 2002, we were just at a lab scale. We were basically at the point where it was a research project, an academic research project that became a spin-out out of Queen's University that we aimed to commercialize. So from there, we moved to pilot scale very rapidly in the middle of 2022. And then at the end of last year, we constructed a demonstration scale plant that can produce around 10 tons of separated rare earth oxides per annum. And we commissioned this facility at the start of the year, and continuous 24/7 production started in March of this year, which then demonstrated the commercialization of which was in essence just a year ago a science project. Now, we have a full program for the next 18 months, because since we demonstrated the production and sent it off to a number of off-takers, we are fully subscribed for the next 18 months in the production capacity that we have in the demonstration plant. So subsequently, we've been looking at debottlenecking opportunities in the demonstration plant just to see if we can meet more of the demand out there, which is pretty high. This being recycled and secondary supply REOs, and that's pretty important, as I'll explain a little bit later. And then we're also busy with a feasibility study for a full-blown commercial facility, anything from 200 to maybe 1,000 tons per annum capacity. So this feasibility study is expected in the third quarter. We will then move through the natural process of getting the funding for it, doing the engineering and design, construction commissioning, and then we're looking at full operations in 2026. The last point on Ionic Technologies is the European Critical Raw Metals Materials Act, and now it will make more sense why Belfast is such a good location for us, the dual market access and so forth. So the specific piece in this act that applies to Ionic Technologies and is really driving the demand for our specific product is the point on the requirement of the act for at least 25% of the EU's annual consumption of critical metals to come from recycling. So that's just a bit of an overview of Ionic Technologies and where we are with it. Moving on to our second subsidiary, which is Renzori Rare Metals, which owns our Makutu project in Uganda. So the headline at Makutu this year was the first production of mixed rare earth carbonates. So we designed and constructed a pilot plant, demonstration plant earlier in the year. We commissioned it, and in March we produced the first mixed rare earth carbonates. Mixed rare earth carbonates. That was the first batch of our production, and we're using this in all the negotiations and conversations with potential strategic partners. Then another important milestone that was met at the start of this year was the award of the mining license of the first of our tenements. We have 6 tenements that spans roughly 40 kilometers. It's 300 square kilometers, and the base case of our feasibility study is based on the first mining license area. And we're also now updating the MRE, and that's expected in this quarter, so that we can support the next mining license application, which is due in November of this year. This is a large-scale ionic adsorption clay project, and the really important thing and where the true value of the Makutu deposit lies is in the fact that 70% of its rare earth basket is magnet or heavy rare earths. And that's why it's such a strategic and critical asset to develop over time. If we just looked at previous presenters' positions on demand, on the market, on what's required, on what's valuable, Makutu has what's valuable. 70% of its basket is the heavy or magnet rare earths. Now, Ionic currently owns 60% of Rwenzori rare metals, but we've already agreed to move that up to 94%. There is a mineral resource estimate and stage 1 ore reserve estimates that are completed. The environmental permits are approved. The ESG certification by Digby has now run through its second year with a little bit of an upgrade. The stage 1 feasibility study is completed, and that stage 1 just refers to the first mining license of these 6 that we hold. And of course, the demonstration plant that's now producing MREC since March and continuing to do so. So the stage 1 feasibility study really, in a nutshell, comes down to low capital cost full-blown mine development of around 120 million US, and we're looking at 5 million tons per annum throughput, and the maiden ore reserve for the Makutu stage 1 over that first mining license area is probable 173 million tons at 850 ppm total rare earth oxides, but again keeping in mind that 70% of that is the heavies and the magnet rare earths. And then, of course, the other value is the staged growth that we can develop, or the modular design philosophy around Makutu. Just the first license has a life of mine of 35 years. There's still 5 more to go. So it's a very large scale resource. So just in a nutshell, Makutu is development ready. It's produced MREC, and we're continuing to develop and do all the work required to move it forward. So talking about the joint venture that we've recently announced with Viridis, what's the purpose? The purpose is to construct a refinery and magnet recycling facility in Brazil. And the agreement is that Viridis will provide the MREC from their Colossus project, and Ionic Technologies will provide the separation technology. We have initiated a scoping study on the refinery and recycling project, and we expect that to be done at the end of this year. More to come. That's just the corporate snapshot. The market capitalization at the moment is just over 80 million. Cash position at the start of the year was 4.5. It's a little bit less now. And then what is the Ionic value proposition? Direct exposure to heavy rare earths market growth, as I just explained in the presentation. Ionic Technologies, who has demonstrated that it's not just a science project now, it's a commercially viable technology. It's produced, and it's produced at scale as well. Low capital opportunities to develop the resource at Makutu. The strategic importance is one of the few ex-China supply options out there, and the geopolitical tensions driving the demand for secure and resilient alternative supply and also secondary supply. And then the downstream refining potential to unlock the value of the Makutu basket specifically. Thank you very much.